Hi students, it's Chase with Star Tutors, and we are here to run through the SAT Math 2 Level 2 subject test. For those that have taken this test before, you'll know that there's a Level 1 and there's a Level 2 subject test. This is the Math Level 2 exam. And not only are we going to walk through this test, or we're going to do this test in real time, I should say, for those that have watched our ACT and SAT videos before, you guys are familiar with how this works. We're also going to talk about how the scale works on the SAT Math 2 test, because it's a little bit different, and thus the strategy is a little bit different than what you'd see on the normal SAT or if you've taken the ACT exam. So we'll talk about all those things. Before we get going, guys, don't forget that that we do have our Star U tutoring app. It's free to download in the App Store, and we actually have an awesome new feature that just came out. It's our Smart Bubble Sheet. So what you can do now is you can take a real SAT or ACT exam, plug your answers into our Smart Bubble Sheet on your phone, on your tablet, on your computer, and right away the app will give you suggested study tips and help. So we highly recommend that you check out that Smart Bubble Sheet. Again, the app is free to download in the App Store. It's Star U. Check that out. We highly encourage it, and we think it's going to really help with those SAT tests and those ACT exams. So look out for that. Without further ado, though, beyond our talk about SAT and our Smart Bubble Sheet, all that kind of stuff, we are here to show you how this SAT Math 2 test works, how you should try to approach it, this real-time exam. And yeah, at the end of the video, if you guys like what you've seen or you've seen our other videos before, please subscribe to our channel. Also look at our membership program, which is now available through YouTube. You can check that out below. But if nothing else, please subscribe. It's free, and that'll give you guys notifications for any new videos we have coming out in the future. All right, so having said all that and getting that all out of the way, let's talk about the Math 2 test. So there's a couple things that you guys need to know that's very different from this exam versus an exam that you'd see than the real SAT exam. Specifically, the scoring is a little bit different. So let me tell you a little bit about that. The scoring on the SAT Math 2 test is different in two ways. One, and this is very, very important, please write this down and take notes on this, there is a penalty for guessing on the SAT Math 2 exam. On the SAT and on the ACT, with the normal exams that you take right for college, that does not exist. There is no penalty for guessing. You don't get marked down for that. This is a different test. You do get marked down if you have the SAT Math 2 test and you guess an incorrect letter. So basically how that works, and again, this is you guys might see this answer sheet come up. Basically how the scale works, these are just two scale scores that I found online, so you guys can do that as well, and we'll post all of the links to find these exams. When we get into the real exam here in a second, you guys will actually have the real exam in front of you, hopefully, and you'll be able to take that test, and then you can implement your own strategies. Watch the video after you take your own test and see what maybe you did differently than what I do, and so on and so forth. But I can assure you guys that this is just an answer sheet and a scale that I found online. I can confirm that it is a real SAT Subject Math 2 test. It is not the one we will be taking today, so if you're worried about me seeing the answers or anything like that, I have not, and just so you guys know that, and we get that out of the way up front. But one of the things that's very different is, like I said, you do not get penalized for guessing on the real SAT and the real ACT, right? On the big test, the normal test. On this test, you do get penalized. Okay, so on every SAT Math 2 test, there are a total of 5 answer choices. Okay, you'll have 5 answer choices available. Okay, and if you guess, and if you answer a question and it is incorrect, not only do you miss that question, but you also get a subtraction of 1/5 of a point. Okay, you lose a 1/5 of a point for incorrect answers. Now that's different than omitted answers, and it's also going to really play into our strategy today. Because on the SAT Math 2 test, more than anything else, you need to be disciplined. Okay, if you don't know how to do a question, and I'm going to try to walk you through that today, when I don't know how to do something, I'm just going to move on. You don't want to guess incorrectly, because if you do that and you have a total of 3 answers, so let's say you miss 3 questions, but rather than omitting them, you miss them and you get them wrong. Well, on top of that -3 out of the 50 total questions, you also miss an additional 1/5 times 3. Okay, and what you guys will see is that's -3/5 of a point, and the SAT and the ACT round up and down. So in reality, you've missed -3 3/5, right, or -3.6, and so now you've really missed -4 points. You've actually missed 4 just by filling in bubbles that you weren't totally sure of. And so it's very, very, very important that you remain disciplined, and that if you don't know how to do a question, the pass method that we continue to talk about, on our other videos. If you haven't checked out our other SAT math videos for the regular SAT math sections or our ACT math videos, please do so, because this pass method that we talk about is even more critical, right? On this video, it's going to be the 2-pass method instead of the 3-pass that you've seen in other videos. But it is so critical that you only answer the questions that you 100% know how to do first. You come back, you answer some of the more time-consuming, maybe the more difficult questions next, but that you do not bubble in answer choices for anything that you're not 100% sure of. And the great thing about this is if you can remain disciplined, right? And let's say you miss, you just omit, right? We're going to keep using this word, we omit, which just means we skip it. If we omit questions on this, let's say we omit 6 questions, so we lose 6 questions, look how favorable and how great the SAT Math 2 scale is. So again, this is just a test, and again, I confirmed that this was a real test scale, right? This is just a test that you pulled offline. If you get 44 out of 50 questions correct, that's an 800. That's a perfect score on this exam. 44 out of 50. Okay, so it's very, very important that you recognize that you don't need to get every question right. This is the best situation in the world. If you miss 6 questions, you get a perfect score. I found another scale. You guys will see this pulled up in the background here in just a second. On another scale, a different test, you guys will see the exact same thing. Okay, so on a different test, completely separate, and this is very true of the SAT Math 2 exams, you'll see that you get a score that you can effectively miss, right? You can miss a certain number of questions and still do extremely well on this exam. Okay, so you can miss let's say between 5 and 8 questions per SAT Math 2 test. If you just omit those, if you leave those blank and you remain disciplined, you look for the questions that you 100% know how to answer, well, guess what? Then you are going to be in great shape. Because here's another example of a scale where on this test, you could miss 7 questions, right? You could miss 6 on the last one. This is another official test. It's not the one I'm going to be taking today in case you're, again, worried about the answers. This one you could miss 7 questions, or I'm sorry, you can omit 7 questions, right? You can leave 7 questions blank, and you can get an 800. But what happens if we answer every question? Well, if we were to answer 7 questions and we were to miss, right, we missed those, instead of just leaving them blank and being disciplined, that really is 7, and then we have to multiply that again by 1/5. So we'll miss 7 questions. Instead of omitting 7, we actually miss 8 or 9 questions. And so again, it's so critical that you remain disciplined. And the best part about this is it should take away all anxiety, because if you know you only need to get 43 questions right out of 50, and that guarantees you a perfect score, then by all means you need to be finding the easiest questions first, and then you can worry about harder questions. Going into every one of these Math 2 tests, and this is true when I was in high school and it's true now, and this is what we teach in our programs, you need to be finding the easiest questions first. I know going into this test that if I miss 6 questions, in all likelihood, if I get 6 wrong, let's say 5 wrong, if I get 5 wrong, or I omit 5, I should say, I keep messing that up. If I omit 5 questions, right, 5 questions omitted, and I just don't answer them, I don't bubble them in because I'm disciplined, I will 99% of the time get an 800 at -5. And most of the time, I'd say 50-50, if you miss 7 questions, you'll still end up with a perfect score. And if not, if it ends up being that the scale it affects you in a dip, it's not -5, or rather it's not -7, it's -5 to get a perfect score. Look, you still get, if you miss 2 additional questions, you still would get a 780 if the scale was a little bit different. So in any case, again, it is so critical that you omit questions. So what we're going to be working on today is what we call this 2-pass method. For those that have watched our other videos, we call it the 3-pass method in other videos, because the 3rd pass is when we guess. On this one, we're going to not guess, right? We're going to leave those questions omitted. So on the first pass here, what we're going to do is we're going to look to answer all of the easiest questions first. Okay, easiest 100% questions first, and I'm going to skip any question that looks even remotely difficult to me. I want to make sure that I get every question with 100% accuracy with as much time as I need. I need to get all of those questions right first, because ultimately if I leave questions blank, that's actually a help rather than having to guess at the end. And then on the second pass, with whatever time I have remaining, right, second pass, banked time, now we're going to be looking at all of the more time-consuming, more difficult questions, with, again, the intention of missing, let's say, 7 total questions to get a perfect score on this exam. 6, maybe 5. Let's set the example at 5. We're going to try to get 45 out of 60 questions right today, or 45 out of 50, rather. we'll have 60 minutes to do it, but think about how much pressure that takes off of us. Instead of thinking about this as a 50-question test, if we really understand the scales, which is our whole goal of this video, the scales tell us that we only really need to answer 45 out of 50 to get a perfect score. So our goal should be, this is a 45-question test that I get 60 minutes to complete, not a 50-question test. Because whatever time we were going to spend on those 5 difficult questions, we're going to take that time and we're going to apply it to guarantee that we have accuracy on the other 45 questions. Okay, so hopefully all of that makes sense. I appreciate you guys listening to the spiel. Without doubt, understanding the scale of not only the SAT Math 2 test that we looked at today, but the SAT regular test and the ACT regular test, those composite scores, understanding the scale, if you get ahead of the game on that, the sky is the limit on this test, because you're going to see a similar type of scaling, maybe not as favorable on the regular exams as compared to the SAT Math 2 test, but the scaling is in your favor every time, and you need to understand that because it'll take so much stress and anxiety off this test. Okay, so again, hopefully all that makes sense on the scale. If you guys have any questions on that, make sure that you comment below so that we can answer those. We're happy to answer any questions about the scaling. And now we're going to jump into the real test where we take the full exam in real time over the course of 60 minutes. Owen will populate a timer on the screen just below the video here in just a second. You guys will see that, and then you'll see the exam pop up as well. Okay, so hopefully all this makes sense, guys. If you have any questions, like I said, comment below. Otherwise, let's get all set up here. And again, if you guys want to follow along or if you want to take the exam yourselves, the one that we're taking, you guys can read the description below. I encourage you guys, if you are going to take the test, take it on your own first. Do it on your own first, and then come back and watch the video so that you can observe with your own test in front of you and implement strategies that you think worked well that I did and customize it to your own strategy. Okay, so without further ado, let's pull up a timer here. Okay, so 60 minutes. Okay, and again, the same timer will populate below the screen here, so you guys can follow along. And without further ado, one last thing, guys. You can use your calculators. The SAT Math 2 test is very lenient on which calculators you can use, more so than the ACT or the SAT. So make sure that you guys check that out. We'll post the calculator policy for the SAT Math 2 test in the description below, just so you guys know. If you have a TI-84, that's what I use. TI-84 is the most common TI calculator on the market, maybe the most common graphing calculator on the market, so you're totally fine using a TI-84 if that's what you have. And again, that's the most popular calculator on the market, so I assume many of you guys have that. So in any case, guys, we'll post the calculator policy below. If there's nothing else, let's get through it, okay? And I'll try to explain what I'm doing throughout the video. And with that in mind, our timer starts now. Okay, pass 1, we're trying to find all of the easiest questions first. Okay, so this is, okay, so SAT Math 2. Okay, right away, I'm going to skip number 1, because even if this is an easy question, I think I'm going to have time. By skipping it now, I know I can come back to it, and I skip it right away. Anytime this word starts with the word if, the chances of making a simple mistake early in the test, and I don't dispute that number 1 is probably not going to be that hard. If it starts with if, there's a million different simple mistakes you can make on any math test. So I'm looking for a question that's more rules-based, like number 2, right? Number 2 looks like a distributive property question. So I'm going to distribute this in. So I get A over B plus A over C, and let's see if we have one of those answers. We do not, so we have to multiply, right? We have to find a common denominator, so we're going to multiply this by C, so we get AC over BC plus AB over BC. And guys, again, I just multiplied here by C over C, and then B over B for the next one to get a common denominator, so we get AB plus AC over BC, so the answer should be 2. The answer should be, number 2 should be D. Okay, so let's keep going, let's keep rolling. That was number 2, and again, that was a rules-based question that I felt pretty good about, so I knew that I could answer it. I love sine and cosine questions, so I'm going to answer this one as well. Usually sine graphs and cosine graphs especially, even more so than just functions of sine and cosine, graphs make it very easy, and that's something you should probably answer, because you get when you get a figure, it's just seemingly so much easier to answer these questions, okay? So let's look at this one. Figure 1 shows one cycle of the graph of the function y equals sine x. The minimum value of the function occurs at point P, then the coordinates of P are. Okay, so y equals sine x, we know that this is 2 pi, so this would be 3 pi over 2. So right away, I'm going to eliminate all of the answers that are not 3 pi over 2, so we get these 3. One thing that I've noticed, guys, recently about the SAT, the ACT, and the SAT Math 2 now, a lot of times you'll notice that they give you 3 answer choices with the correct, one of the correct coordinates in it, or 3 answer choices with something that's correct, and the other 2, you look out for this. It happens a lot, and I've mentioned it in another one of our videos, but 3 pi over 2, 3 pi over 2, 3 pi over 2, there's 3 answer choices like that, so that kind of leans towards the idea that that's probably the right answer. Hopefully that makes sense. If you guys have any questions in that comment below, and I'll try to answer it when there's less of a time issue. Okay, we got to get moving here. So number 3 says, the point, let's see, and looks like sine graph. Yeah, so this should just be D again, because the amplitude of a sine graph is just 1 to -1, right? So I think that's pretty straightforward. If point P are different points in a nope, not answering. 4 is one where you can get so jumbled on that, and our goal is just to get 45 right. Maybe we come back to that and it's easy, but for right now, I want to keep this momentum going with just these rules-based questions that I feel really comfortable about. Okay, so this next one, if 6y, anytime we get an algebraic problem, it's probably not going to be that hard. We get the square root of 6y is equal to 4.73. Right, and now we're going to square both sides, so we get 6y is equal to 4.73 squared. Now we're going to divide by 6, so y is equal to, let's see, 4.73 raised to the second, divided by 6 is 3.73c. Okay, and again, that's just a basic algebra problem that shouldn't give you guys too much trouble. If you just memorize that basic algebra stuff, that one shouldn't give you too much trouble, hopefully. Let's see. Okay, we're doing okay on time. I'm yapping a lot, so I'm trying to watch that. In figure 2, r cosine theta equals, okay, r cosine theta. Again, anytime you're given a figure, and I love trig, and geometry and trig have always made sense to me, and this is one that I definitely want to try to answer. If r cosine theta equals something, okay, so theta is equal to, we're looking at cosine, so this is just adjacent over hypotenuse, right? So cosine of theta is just equal to x over r. So it's just equal to x, right? That's a rules-based question that you're just looking for, right? So, TOA, adjacent over hypotenuse. So I think that one's pretty straightforward. Let's see, 7, I like functions questions as well. If f of x is equal to that, then g of f of 10. Okay, so g of f of 10, all we have to do is plug in 10 and solve it for f, right? So we're gonna say f of 10, let's do that one first. Make sure we don't make a simple mistake, is equal to the square root. And anytime you guys know that you have functions, we're just plugging it in. 0.3 times 10 squared minus 10. So that's equal to 100, so that's equal to 30 minus 10 is equal to the square root of 20. Okay, I think, right? The square root of 20. Hopefully I didn't make a simple mistake there. Okay, and now when we know that f of 10 is equal to the square root of 20, now we're looking for g of f of 10. So now we plug in the square root of 20 into our values of x during the g equation. So we say root 20 plus 1 over root 20 minus 1. And guys, if you even in the worst case scenario, if let's say your calculator runs out of battery and you weren't prepared for that, remember that the square root of 20 is like somewhere around 4.5 because 16 is 4, right? Square root of 16 is 4, square root of 25 is 5. That's like somewhere around 4.5. So we're saying like 4.5 plus 1 plus 4.5 minus 1, and we get what? 5.5 over 3.5, which gives us something like 1.6. Now I am going to use my calculator to confirm that, but I think, right, that 3.5 should be somewhere around 1.6, because if you double 3.5, you get 7, so it's not going to be 0.2, it's not going to be 4.5, it's not going to be E, and I can probably assume that the answer is C, 5.5 divided by 3.5 to confirm, yeah, 1.57, so I feel pretty good with saying that's C. But that's a great example of where technically speaking, on the SAT Math 2 test, they designed this test so that you should never actually need a calculator. Now, of course, it's better to use one to confirm things, but you actually don't need one. So continue to think about that. If your calculator runs out of battery, worst case scenario, you can still work through a lot of these questions if you're still looking for the easiest questions and just taking a deep breath and trying to logic your way through it. Like, what is 5.5 over 3.5? What's the square root of 20? Well, it's got to be pretty close to 4.5. I don't know it for sure, but I know it's got to be pretty close. Okay, I'm going to skip question number 8. I can't stand those real number questions. They just drive me crazy. Let's see if I can find in number 9. In the triangle in the figure below, if OA, so mark up the page as much as you can. If OA is equal to AB, what is the slope of segment AB? So we get this right here. This is 0, 0. So drop this down. That's 2 then, right? That's 2. Do we know anything else? We don't know. That's a right angle, but we don't know what those angles are. We can't confirm that that's 45, 45. Like these would be 45, 45, 90 special right triangle. I'm going to come back to this one, guys, but I think the answer is E. And it's so hard to guess that sometimes, but because it's no, right, you always think it can't be that answer choice. But I just think that it has to be because I don't see another way that it could be. We don't know any of the angles, so we can't use like law of sines, law of cosines. We're not given any of the angles. We know that they're equal to each other, the base ones are, but that doesn't give us much. We'll come back to that one. Okay, we're defined cosecant 2 pi. So remember, what is cosecant? Remember your trig identities. Cosecant is just 1 over sine, right, 2 theta. And that's going to be times sine 2 theta. Oh, that's super easy, right? Sine 2 theta over 1. Those cancel, that's just equal to 1. That's A. So that's an exact type of problem that if you know your trig identities really well, this test almost is, in some ways, if you know the concepts really well, this test can actually be easier than the SAT regular math sections. And now, not to say that these concepts aren't a lot harder, they are, but the SAT regular math puts things into, it jumbles words, it just makes it more confusing than it probably needs to be. The great thing about the SAT Math 2 test is it is very straightforward. Like, what the question asks is exactly what the question asks. And so that means that if you know your trig identities or if you know your sine graphs or whatever it might be, those questions end up being very, very straightforward and very easy. Let's see if this next one. So generally speaking, 11, let's see which of the following could be the graph of y equals f of x. So anytime you have y, if you take the absolute value, remember it doesn't, wherever it dives down to the negative, it actually flips and it goes back up. So in this case right here, right, this whole area would flip and come back up. So I think the answer just has to be E. Right, absolute value is always positive. So this negative value, this negative part of the graph, flips up to form the absolute value. I think that's right. We'll maybe come back to that one, but I'm pretty confident on that. Let's keep going. If 3 and -2 are both zeros of the polynomial, then a factor. Okay, so guys, yeah, look out for factors and zeros. I can't stress it enough. In all of our classes for SAT, for ACT, we always talk about how important it is to understand the difference between zeros, roots, and x-intercepts. Those are all the same thing if you ever see those words. And factors. What a zero means is that you just set that means that it's x equals x equals 3 and x is equal to -2, right? That's what a zero is. And now what a factor is you just add that back over and set it equal to 0, right? -3, -3, so you get x minus 3. That's your factor is equal to 0. And we get x plus 2 is equal to 0. So these are factors. When they're set equal to 0, they're factors. When their x is equal to something, that's when they're roots or zeros or x-intercepts. Those all mean the same thing. Okay, and now, okay, it's a polynomial, so now it looks like we don't get any one of x minus 3 or x plus 2, so it just means that we have to multiply these together by foiling, so we get x squared minus 6 minus 1x, so b. Right, we're just going to FOIL that out because they give us, that means that there's another term, probably, in the polynomial. A kite string is attached to a peg. Oh, okay, yeah, guys, this is a good one to draw out. A kite string is attached to a peg in the ground. If 100 meters, right, it's probably going to be a trig question because they give us a degree. Be really careful on these to make sure that you know what they're asking. If 100 meters of kite string are played out on the kite and the string makes an angle of 49 degrees with the ground, what is the distance? Okay, so if 100 meters of kite string are played out on the string, so I think that's like this, right? And this is the 49 degrees. From the kite to the ground. Yeah, because I think that this is what they're looking for. Right, and we can picture our kite up here. And we got our guy flying it. So they're looking for this, I think. And this says that 100 meters. So this is just becoming a trig problem again. This is a common problem. If you guys have taken physics before, this is a very common problem in physics. And so then we just get opposite over hypotenuse. So sine of 49 is equal to sine 49 is equal to x over 100, right? So katoa. And then we multiply by 100. So 100 sine of 49 is equal to 75.47. So 13, I think, has to be C. Okay, I think that's right. Okay, what's our time? Okay, 40, yeah, we're doing okay on time. Let's see. 14, this shouldn't be too bad. If f of x equals 3x plus 5, if f of g of 1 equals 11, which of the following could be g of x? Okay, so this is saying when g of 1, but we got to solve for x, I think. Oh, no, we don't. Because we're saying 3x plus 5, 3x plus 5 has to equal 11 when you plug in g of x, right? So this is saying 3g of 1, right, plus 5, that's how we do this problem, is equal to 11. And so now we subtract the 5 on both sides. So 3g of 1 is equal to 6. Right? I'm just plugging this in. I'm just plugging this in, right? Because f of g of 1 means that you just plug in g of 1 wherever the x value was for the f function. So now we get 3g of 1, and we're going to look for what multiplies. If I plug in 1 to these equations, I need this to be 2, right? Because I need this to be 3 times 2. So when I plug in 1 to a, 7 times 1 minus 5 is 2. Just to confirm, let's make sure that none of these work. No. -5 plus 3, that doesn't work. Yeah, it's got to be a. Okay, because when I plug in 1, I get 7 times 1 is 7, minus 5 is 2, 3 times 2 is equal to 6, and so that should work out by just plugging in that value. Let's keep going. 14, figure 5 shows a cube. Again, guys, I like the geometric problems or the trig problems. I like triangles. They've always made sense to me, so I'm going to try this one. Figure 5 shows a cube with edge length of 3 centimeters. Is points A and C are midpoints of the edge of the cube. Okay, so these are 3, right, for this cube. A and C are midpoints. So I think that means that this is 1.5. Although it doesn't look like it, guys, that doesn't look great in terms of the figure. We're looking for the perimeter of the region. Okay, so I think this says this is 3, so this should be 1.5, right? And that would mean that this would be some value of C, because now we have a Pythagorean theorem problem. I think that's right. That seems relatively easy, but particularly because A and C don't look like midpoints there. Let's see, it comes down here. It's a relatively early question, so I don't expect it to be that bad. Now that I've started it, I should probably try to finish it. 1.5 squared plus 9 is equal to 11.25. So C squared should equal 11.25. And look, they give us this answer, right? 11.25 is not going to be the right answer because C then is equal to the square root. Second square root, second answer. 3.35. 3.35. But remember, guys, that's not all they're looking for. They're not looking for the edge length. They're looking for the perimeter of the inside plane. So now we have to multiply that by 4, and we get 3.42 C. I think it seems right. It seems about the difficulty level 2. Okay, an equation of line figure 6 is, it can't be that. This is the 0, 0. That seems wildly easy, but I think that's just B, right? This is y equals 2. That seems very easy for that question, but I think that's, I don't know, I guess we'll see. That seems 0, 0, yeah. It's very straightforward, so I don't know what else we could probably get from that, so I'm going to go with it. The mean weight of the 19 members in algebra class. Okay, so I love means, so averages, medians, and modes. Going back to that app stuff that we talked about earlier, we have a big section on averages, medians, and modes, means, medians, and modes. So very important that you understand that if you have a mean, the most important thing when looking at averages is actually the sum. Okay, because theoretically, we can say that if 19 members of an algebra class were each 112 pounds, that's what the mean is, we can assume that all 19 members, right, because of the way averages work, we could just assume, I don't know if this is true or not, but for the purpose of an average question, we can just assume that all 19 members weigh 112 pounds. They're probably not all that, but theoretically they could be. All 19 or weigh exactly 112, and there's your average. So we get 19 times 112. So the total weight of that class right now is 2128 pounds. They all weigh, if you combine all of their weights, And that makes sense, because then if I were to add up all their weights, even if they were different weights, like even if they weren't all 112 and I divide that by 19, that's how I get my average, right? So they have a total. That's why the sum is the most important part of an average problem. They have a total sum of 2128 pounds. And it says when a new student enrolled, the mean decreased to 111 pounds. Okay, so now the mean is 111. So we have 20 students now times 111 is equal to 2220, 2220, right? That's the new student, and now we just subtract 2128 from that value, because that was the old student class, and now we do minus 2128, and we get 92 pounds. So the new student that came to class weighs 92 pounds, and that's what you'd have to, that's how the average was decreased by 1 total pound for the class, was because the new student weighed a lot less. Okay, so let's keep going here, if I can get this working. Let's see, so we're getting a lot of rules-based questions, and that tends to happen early on in the test, so it's not totally unexpected that we get these, but again, it's important. How much time we get? 18, okay. It's important that we recognize this, rules-based questions. We're 18 minutes in. Cosine x is equal to 0, so what is the value of tan? Okay, so guys, if we know that cosine x, right, cosine x is equal to 0.875, what is the value of tan of x over 2? That just means that cosine of x, let's put x here, this would be 0.875, and this would be 1, right? Because that would be, if we do cosine of x now, we get 0.875 over 1, right? Which is what we're looking for. And so now we're looking for the tangent, so we just do 0.875 quantity squared plus b squared is equal to 1. So 0.875 squared is 0.76, 0.7656. We're going to do 1 minus second answer, 0.2343, and then we second square root that to get our b value. Oops. Second square root, 0.234375. We get 0.48, so this is 0.484. Okay, now we get the cosine of x, or sorry, the tangent of x, x over 2, is equal to 0.484 over 0.875. Second, right, now we do tan negative 1. The inverse tan of 0.484 divided by 0.875, and we get 28.94. So, wait a second. Uh-oh, guys, x over 2. Guys, I'm going to come back to this one. I got to start 18. I spent too much time on it. I'm close. I know I'm doing something right. I'm feeling confident, but let's keep going. Okay, so 19 recently voted on for total of 302 guys. I'm gonna keep going. 19 doesn't make 20 is more rules based, right? So if f of x, y transitions to x plus 2y for every pair of the plane, what is it true? What point is it true that xy is equal to xy? Okay, so they're asking if you have this translation, what are the values of x and y have to be in order for them to equal each other? So the set of points xy such that x is equal to 0. So if we do 0 here, and then this goes to, this is the x value, and then we need it to go to 0. No, now it's 0 plus 2y, right? This is just for our x values. We need the y's to stay the same. So this should be, this should be, we need x, comma, 0, right? We need y to be 0, because if we get x, if y is equal to 0, which would be b, right? If y is 0 in all of these, then we get x comma 0 for the first one, and that translates to x plus 2 times 0 comma 0, and x plus 2, 0, right, is equal to x, so then we just get x is 0 again. So any value where y is equal to 0, that translation ends up being at the same point. Okay, so that should be 20. That's a rules-based question. I feel pretty good about that one. Hopefully, right? 21. What number should be added to each of the three numbers so that the resulting three numbers form a geometric progression? Okay, geometric progression, guys, just means you're multiplying by the same number. So like 1 times 2 is equal to 2, times 2 is equal to 4. So the geometric progression would be 1, 2, 4, 8, right? That's what a geometric, I encourage you guys to look that up if you haven't already. We gotta keep moving. Yeah, I encourage you guys to look that up if you haven't already. So let's see, 1, 7. If I add 2, I get 3, 9, 21. That doesn't work. They have to be consistent. 4, 10. That doesn't work. 5. If I add 4 to all of those numbers, 5, 11. That doesn't work. If I add 5 to those numbers, 6, 12, 24. That works, right? Because 6 times 2 is 12 times 2 is 24. That's a geometric progression. If ax for all real numbers x, and if f of 0 equals 1 and f of 1 equals 2, then man, okay, so this is a systems of equations question. This is going to be f of x, when x is equal to 0, y is equal to 1. So we know that c then is equal to 1. That's a really important thing to know. If whenever x is equal to 0, you have your y-intercept, which is always equal to the constant. So we get f of x then, f of x, should be c is equal to 1. So we get ax squared plus bx plus 1 when f of 1, right? So f of 1, we get f of 1 equal to 1a plus 1b plus 1, and that was all equal to 2. So a plus b is equal to plus 1 is equal to 2. So minus 1, so a plus b is just equal to 1. That was one that looked a lot more complicated when we started it out, I think, right? But if you just continue to work through that problem, this is so important though. Knowing that when you plug in x is equal to 0, right, f of 0, that means that it's the constant. It's always the y-intercept of the graph. Of any graph, it's always the constant because you just keep plugging in 0 for x's and they keep multiplying to 0. So that's equal to the constant. If you know that right off the bat, that this point would then be 0, comma 1, and the c is the y-intercept, that all of a sudden becomes such an way easier problem than it looked like when it started. Okay, what is the degree measure of the largest angle of a triangle that has sides of, okay, this is a law of cosines problem, right? So we get 6, 6, and 7. We're looking for the largest angle, which would be here. So we get 7 squared plus 6 squared, 7 squared is equal to 6 squared plus 6 squared minus 2, 6 times 6 times cosine of the angle, right? So this is the angle, it's called cosine C. And so we get 49 equals 36 plus 36 minus 72. 72 cosine of C. That's, again, guys, look up the law of cosines if this doesn't immediately make sense. 49 minus 36. I knew it was law of cosines just to continue to talk through this. I knew it was law of cosines because they gave us 3 sides of a non-right triangle. 3 sides of a non-right triangle can be solved using law of cosines, and so that's why I did it that way. I subtracted the 2 36s across, negative 23 divided by negative 72 is cosine C is equal to 0.3194. And let's see. And then we do just second. I'm in the right mode here. Yep, I'm in degrees. So I do second cosine of 0.3194, and I get 71.37 C. Okay? Let's keep going. What is the domain? Guys, domain is you got to look for the domain in 2 examples. If you have a denominator or if you have a root function. If you have a root function, then everything just has to be 0 or greater. So you just set whatever's equal, whatever's under the root, you just say negative x is greater than 0. Is greater than or equal to 0, excuse me. So then we get minus 13, negative x squared is greater than or equal to negative 13. And we square root, we divide by, we get x squared is, we divide by negative is greater than, that's where they're trying to, you guys remember, we just divided by negative, I almost missed that, and I always talk about that. If we divide by negative, the sign has to flip, so we square root both sides, and we get x must be greater than or equal to, what? X must be greater than or equal to second square root of 13 is equal to, 3.6, right? Is that right? 3.6 oh guys, I'm such an guys, I'm such an idiot. If it's that was such a waste of time. If it's a cubed function, it's got to be e. If it's a cubed function, I was like, that doesn't make, because if it's greater than, but that wouldn't make sense with this question. You'd flip the sign, but you wouldn't flip the sign. So I was confused as to why I would flip this whole thing. But it's a cubic function. If you take the cubic root, right, of -8, that gets you -2. That works. I should have noticed that, right? That's just going too quickly. It's got to be e. The cubic functions, or any odd function, right, for the most part, for the purposes of the SAT Math 2, if there's a huge mathematician out there that knows more than I do, then I'm sure there's other examples where the cube root doesn't work for all real numbers. But in any case that I can think of that applies to the SAT Math 2 test, a cubic function is always going to be all real numbers for the domain, and that was just me going too quickly. Now I've wasted some time, I got to catch back up. If cosine x is equal to tan x, which of the following is a possible radian value of x? So cosine x, right, is equal to sine x over cosine x, right? And then sine x is equal to cosine squared x. Does that help us in any way? Let's think about where tan might equal cosine. I gotta move on, guys. I'm blanking because I'm frustrated that I missed that last question, or missed that cubic and wasted time knowing that that could have been a 2-second problem because I knew the rule. Let's see, in figure y equals 3 to the x, what is the sum of the areas of 3 inscribed angles? Okay, so this is an x value, right? We gotta figure out how tall this ends up being a calculus concept, but we don't need calculus right here, right? We gotta figure out how tall these are because we already know the distance in between each one of these. So all we're going to say is if this is at 4, that means that x is equal to 4. Let's plug that in and solve for y to see how high on the graph we've gone. So we get 3 to the 4th is equal to 81, I think. 3 raised to the 4th is equal to 81. So we know that this point is at 4, comma 81. So this value is 81. If we plug in 2, we get 9. So this value here is 9. If we plug in, right, because this is going to go up to 9, to that point is 0, 9. And then if we plug in 0, we get 1. So this point is at 1. So we're going to get an area of 2 here, an area of 36 here, I think. And an area of 81 times 2 is 162 plus 36 plus 2. We have 200 even? No, we don't. I gotta skip that one, guys. That we're doing that one right. What is the sum of the areas of 3 showing? We're doing this one right for 26, but I gotta keep going because again, the whole goal here is to find the easiest questions. Never lose, right? How much time we got left? Never lose our momentum. We're right at the halfway mark. We don't want to lose our momentum here. So let's see if we can answer a few more of these. When a certain radioactive element decays, that exists at any time, T can be calculated by the function here. Raise the initial amount. How many years would it take for an initial amount of 600 milligrams to decay to 300? Okay, so we're just looking for how long it takes for it to decay into 2. So all we have to do is say 600. Function where A is the initial amount. The initial amount of 600 is equal to a final amount, right? So 300 is equal to 600 times e to the negative t over 1,000. So you can do one of two things. You can either solve for it properly and use natural log, and you get e to the negative t, right, over 1,000. Then we get ln of 1/2 is equal to negative t over 1,000. Multiply by 1,000 on both sides, and we'll get the negative t. So let's see, ln of 0.5 times 1,000 times negative t should be answer to a c. So 27 should be c. I just multiply by 1,000 over 1 on both sides. Anytime you're given an equation within the problem, it's usually pretty easy if you just plug in the correct points at the right. So just plug in your values that they give you. Which of the following lines are asymptotes of the graph? So vertical asymptote is that x is equal to 0, right? Because that's what makes the denominator undefined. So definitely 1. So not 2 only for sure. And then y, oh, so you guys, if you have x plus 1, this is a limits question, starting to get into higher level pre-calculus, into the calculus stuff. If you have the same degree on top and bottom, it's just whatever the coefficients are, 1 divided by 1. So it should be a value of y is equal to 1 for the horizontal, right? There's a y equals 1 value at the horizontal, so that's should be 1 and 3 only, D. And you can never have two, so I should have marked that off. You can never have two, you'll never have two horizontal asymptotes. It'll either be y equals 0, or it'll be y equals 1. You can't have both. Let's keep going. We gotta move. If f of x, right, is equal to, what are the values? Okay. So all we have to do here, this is actually looks harder than it is. Fx, if you guys just remember that on function problems, your only goal is to plug this value into the x, right? That's the whole point of functions. We say f of 2x plus 1 is equal to 2 times 2x plus 1 minus 1, right? And then we get 4x plus 2 minus 1 is equal to, well, that doesn't work. For all real numbers. I'm going to keep going, guys. It was 29. Let me start that one real quick. Got to keep moving, okay, because we don't want to run out of time. So now going to be the coordinates of the center of a circle tangent to the x and y axis. Tangent to, so we have this, right? And if it's tangent to both, it means that the radius has to be equal here, so that the values have to be the same. That could be the coordinates of the center of a tangent line. 2, negative 2, right? Because that would just be below the, it's a horrible drawing, but I think that would be coordinates of the center of a circle, because then you'd be going over 2 and up 2 to get to the center. I think it's got to be D for number 30. That's, again, guys, this drawing should be like that for the y-axis. What is the range of the function defined by? Okay, so we get the cube root of x, right, is just x to the 1/3, and we get 2x minus 1. So let's just see, and we got to be careful. This might be one where we should use the graph. X, let's see, x raised to the 1 divided by 3, and 2x minus 1. Just got to be careful with what this looks like. The range of the function as x is greater than 2, less than 2. So, 2. Well, that should be easy, right? This one should be all real numbers, I think. Yeah, because this is going to go down, right? The range of the function, and then this is going to go up. Yeah. Both of these, the cube, that was bad too. The cubic function or a 1/3 like that, you can those are going to go on forever, right? There is no bottom out. There's no parabola. And then we just get a line for 2x minus 1, so that should be all real numbers. If 3x minus 4y plus 7 equals that, and that equals that for x is greater than 0, then x equals... Yeah, guys, you can plug this in for a value and solve, but I think the easiest way is just to substitute, right? This is just a systems of equations problem again. So we get this plus x squared, 2y is equal to x squared, divided by 2, so y is equal to 1/2 x squared. Right, and then we substitute because we're looking for the values of x, and we're going to substitute this value in for the y up here. So we get 3x minus 4 times 1/2 x squared plus 7 is equal to 0. So we get 3x minus 2x squared plus 7 is equal to 0. And then we can plug in those values for the quadratic formula, but that seems like a lot. I'll come back to this one. Oh, no, we can just plug in these values, right? 1.27 and see which one works. So negative 2. Now we can plug it in because now we've worked it out. So now we can just plug in the values and figure out which one is the answer choice. It should be pretty straightforward. 2.07. I'm going to start with the answer choice B. 2.07 squared times 2. And then we get 3 times 2.07. That didn't work, so it's not B. Let's try C. 2.77. 7 is the second times 2. We get 3 times 2.77. Yeah, it's a C. So I just plugged in these values for x. I just plugged in our answer choices for each of these values of x and solved and figured out which one of those values equaled 0. Let's keep going. If f, okay, this is where you gotta make up some time. So if f of x is equal to log 2x for x is greater than 0, then f, this is the inverse function. So we get y is equal to log base 2x, right? For when x is greater than 0, that just shouldn't matter. We're gonna bring our value over, so we get 2 to the y, and we're gonna get rid of our log, right, is equal to x. And this gives us exponential form, which then allows us to solve, because if you guys remember the inverse function, we get 2 to the y is equal to x, which is the same function as we see here, right? 2 to the y is equal to x, and then we solve for that, right? Oh, I'm sorry, no. Sorry, inverse should be like this. X is equal to log base 2 of y. And now we bump this over and we get 2 to the x is equal to y. So it should be a. Because you're just, to find an inverse function, you just you trade places with y and x, and then you solve for y to get y by itself on one side of the equation again. If x naught is equal to 0, then this is equal to then x3. Okay, so if x 0, then we get x to the 1 is equal to the square root of 6 plus 0. So x1 is equal to square root of 6. X2 then is equal to 6 plus the square root of 6, all square rooted. So x3 then would be equal to 6 plus root 6, plus 6 times plus root 6, like that. It's a really bad problem. Okay, so let's see what that is. The square root of 6, second square root of 6, plus 6, second square root of that, answer, whoops, second square root, second answer, plus 6 again, and second square root of that again, 2.984 C. Again, I was just plugging in those values for the next one down. Ah, man, these get your my back ends of bird. Here shows a triangle inscribed in a semicircle. This happens every time I do one of these videos. I'm like all pumped up and jazzed up until like midway through the test, and now all of a sudden my back is hurting. I'm getting too old, guys. Figure 8 shows a triangle inscribed in a semicircle. What is the area of the triangle in terms of theta? Isn't there a 1/2 AB sine theta? Isn't that a thing? Theta? Is that a thing? Where you get this value would be A, right, and this would be B. And you're looking for sine of theta. So what would that be? A and B. I gotta come back to this one. Let's keep going. Certain experiment, there's a, oh wait, no, actually wait. The tan of theta is equal to A over B, right? Opposite over adjacent. So that means nothing. I'm an idiot. All right, let's keep going. Certain experiment, there's 0.2 probability that any thermometer is used by more. If 4 thermometers are used, what is the probability that all of that are? Okay, so 0.2. If they're all used, what is the probability that all of them are in air? This is actually a really easy probability question. You just multiply 0.2, right, by 0.2 4 times. So just 0.2 raised to the 4th power, and you get 0.016. That's a really, guys, what you'll find as you go through these exams, and if you're looking for only the easiest questions, you'll find that there are really straightforward questions that you can save so much time on. And if you skip questions that are going to give you trouble, and I've already not listened to my own advice in some ways, but if you skip those questions and you keep just moving to questions that you do feel comfortable with, you should be in great shape. Okay, if the magnitude of vectors, this is a question that you either know or you don't. If you've done physics, if you feel comfortable with physics, then this should be pretty straightforward. If you haven't, then this one's going to be tricky. If the magnitude of vectors A and B, so you move on from it, right? It's not going to be an easy question. Magnitude of vectors A and B are 5 and 12, respectively. The magnitude could not be. Okay, so a vector, right, is based on direction, so this might be 12 and this might be 5. But in any case, if you have a vector that's going in the exact same direction, all it can be is 12 minus the smaller vector, right, which would be 12 minus 5. So the maximum value of the vector has to be 7. or 17, right? You could only go to 7, or you could only go up to 17 if you have a vector that looks like 12 here, and then there's another vector of 5 added on, or you can subtract those. So the only one that couldn't be was A, because 12 minus 7 or 12 minus 5 is 7, so that's the least amount of magnitude that you could have for the vector, would be 7, or the most would be 17. Okay, if 6.31, what is the value of m over n? So this should be a log problem, right? 6.31 brought, oh wait, no. Yeah, brought over, right? So then this becomes the log, log, right? Log of 6.31 to the 3.02n, because that log gets brought over, and then this n, if you guys remember, can go out in front, so you get then you get m is equal to n times the log of 6.31 to the 3.02, and then you divide by m, or you divide by n, so then m over n is just equal to log 3.02, this change of base, right, log 3.02 divided by the log of 6.31, and you get 0.599999, so I think the answer has to be D there. Again, that's just a log-based rules question, so continue to look out for those as you guys keep going. Come on, your time. Oh, we gotta move, okay? Let's see, if arc cosine x is equal to 0, and it's gonna be between 0 and that's just gonna be A. Guys, arc cosine is just cosine negative 1, and that just cancels out that cosine. X is just equal to 0. Yeah, that works, yeah. Man, that's, I think, a really easy one. I hope I didn't screw that up. But again, this is what I'm talking about. With the SAT, you can miss so many little words on the regular SAT math sections, which stinks. This is much more like the ACT exam, where if you know the concept, you just know it and you can answer it really quickly. Sometimes it catches me off guard because some of the questions, and I think this is right, but some of the questions seem so straightforward and so easy that you just get caught off guard a little bit by it. So just watch out for that, but I think that's right. The 20th term of an arithmetic sequence is 100. The 40th term of the sequence is 250. What is the first term? Okay, so on this one, guys, it means that 20 is equal to, the 20th term is equal to 100, right? And the 40th term is equal to 250, which means that in 20 terms, right, jumping 20 terms, we've jumped to 150 points in value. So that means that every 20 terms, we get 150 divided by 20, we're jumping 7.5 per term. So all we have to do is say 19 times 7.5, and then 100. So I think this one's got to be negative. Yeah, so this, if you do 19, right, to 19 terms from the 20th term down to the first term, you would do 19 times 7.5, which is the value in between each term, the difference. And so that is equal to 142.5. And then the 20th term was equal to 100. So you do 100 minus 142.5. You should get negative 42.5. Arithmetic sequences, you just keep adding up and up and up. I'm definitely not doing 41. I can't stand these problems where if an n distinct planes, that could go so poorly for me in so many different ways. Whereas like one of these questions, right? One of these types of questions where it's a trig identity, that makes me feel a lot better. Let's see if we can do this one. Okay, if sine theta plus sine negative theta. So let's just say theta is equal to 30 degrees, right? 30. So we get sine of negative 30, which is 3, okay, plus cosine. That just equals 0, right? Because wouldn't we just be doing, well, we'd be adding them up. So we get sine of 30 is 1/2 plus root 3 over 2 plus negative 1/2, right? Oh, plus root 3 over 2. So that would be 2 cosines, right? Because the sines go away then, and you get just 2 cosine of theta. It's got to be D for number 42. Because you get, remember that if you're looking at 30, the cosine stays positive in the first and the fourth quadrant if you look at trig stuff. So I think that one's just got to be D because cosine remains the same. It both remains positive, and the sines go away. I just plugged in numbers for 30 degrees because that's an easy one from the unit circle. Hopefully that makes sense. That one looks terrible. 43 looks terrible. The radius of the base of a right circular cone is 6. So I can draw this out. The radius is 6. Okay, and the radius of the parallel cross section is 4. So it looks like the parallel cross section would be like this. And the radius of that is 4. Okay, so that would be 4 there. That's 6. The distance between the base and the cross section is 8. That's 8. What is the height of the cone? Geez. I gotta come back to this one. Oh wait, no, maybe I don't. 6 to 4 would be just 2/3 of that, right? So these would be similar, I think. That would have to be. I'll come back to that one, guys. Okay, keep going. Indirect proof. Okay, if you know indirect proofs, these ones are pretty straightforward. Let's see how much we still got a little bit of time. Indirect proof the statement: if x is equal to 2, then root x is not a rational number. Could begin with the assumption that indirect proof. So if you guys know indirect proofs, this one would be then x is not, if x is equal to 2, then root x is a rational number. So 2 is not equal to x, right? That would be an indirect proof. It would be the opposite. Root x is rational, so 2 is not equal to x. I think C has got to be the answer for 45. Root x is rational, which would be the indirect proof. Suppose the graph of negative x squared is translated 3 units left. Okay, 3 units left. Negative x squared looks like this. Okay, negative x squared. Now it's translated 3 units left. So 3 units to the left. And 1 unit up. If the resulting graph represents what is, this has got to be y equals negative x plus 3 squared, right? Plus, and 1 unit up, plus 1. And I think we just plug in negative 1.6. So negative 1.6 plus 3, right? Because that's the shift to the left. Then we square that. And then we make that negative. Plus 1 is negative 0.96, I think. Okay, I think that's because this all equaled negative 1.96 plus 1. I think if we set that graph up right, we should be in good shape. Because this shift, remember, this negative has no effect on the shift. This is all inside, and that negative remains the same, so that it's facing down. In how many ways can 10 people be divided into 2 groups? 1. Okay, we got to keep going. That's a permutation. That's not great. What is the length of the major axis? Okay, I think we can get this one. This length of the major axis of the ellipse. So ellipses have to set it equal to 1. So you divide by 150. So you get 60 x squared over 150 plus 30 x squared, 30y squared over 150 would be equal to 150 over 150. So that would be equal to 1. And then we do divide this by 30. Right, so this cancels the 30, so that becomes 1y squared. If you divide by that's 5. By 30, yeah. And then if you divide this by 60, you get 1, and this is 2.5. So this is the major axis, is the y, and we get that would be then a squared is equal to 5. Square root both sides. A is equal to the square root of 5, which is probably just over 2. So let's see, square root of 5 is equal to 2.23, so the answer should be D there. If you know the ellipse equation and know that it needs to be set equal to 1, that should be relatively straightforward. Under which the following conditions is A minus B over A be positive. Okay, so guys, I'm going to go all the way back to the beginning because I don't want to. Those questions are going to get harder as we get further along into the test. Doesn't mean that you can't see an easy question, but generally speaking, you're going to see harder questions as you go through the test as a group. So now we come all the way back to number 1. We have how much time left here? We have about 9 minutes and 15 seconds, and I don't know how many questions we skipped, but I know that we have some easy ones at the beginning that I don't think are going to be that hard, but I skipped them because I didn't want to make a simple mistake early. So if 1 minus 1 over x equals 3, minus 3 over x, then 1 minus 1 over x is equal to what? Okay, so 1 minus 1 over x, right, is equal to, 1 minus 1 over x is equal to 3 minus 3 over x. Add 3 over x on both sides, so we get 1 minus 2 over x. 1 plus 2 over x is equal to 3. 2 over x is equal to 2. X is equal to 1, I think. That's not even an answer. Uh-oh. What did I screw up? Plus 3 over x is 2 over x, right? Minus 1 divided by 2 on both sides, by x on both sides. 2x is equal to 2. Oh, x is equal to 1. That's true. Then we get 1 minus 1 over x, so we get 1 minus 1, so the answer should be B, 0. Okay, because that's not what they were looking for. I think that's pretty good. Again, let's keep going. Okay, if P and Q are different points in a plane, the set of all points in the plane that are closer to P than to Q is the regional plane on one side of the line, the interior of a square, the regional plane bound by a wedge, the interior of a circle. I don't know, guys. I'm going to leave that one blank. This is where the discipline comes in, right? We got to be thinking, just a second, though. Plane. P and Q are different points in a plane. P, Q. Regional plane on one side of the line. So it doesn't seem that hard. I actually think this one's probably A. Because points of a plane are always dictated by a line. If you think about a coordinate plane, I think that one's got to be A. I think I was overthinking that one at first. Okay, let's see. If N, P, and T are non-zero numbers, and if N, then N is equal to, G's. T to the negative 9. So N to the 4th, P to the 7th, T to the 9th is equal to 4, N to the 3rd, P to the 7th, T to the 9th. We're looking for N. All right, so that cancels with that. That cancels with that. 4, oh, there we go. 4, N is equal to 4. That was way easier than I thought it was going to be. So I think number 8's got to be C. Unless I made a simple math mistake, I think 8's got to be C. 9 was, I'm going to go with that. We did that one out. I think it's hard to select E, but I think that's right. I think these ones are right. That looks good. So again, I've answered all of the easiest questions knowing, let's see, this was one, cosine x equals 0.875. What is the value of tan x over 2? Well, wait a second. We can solve for x. God, I'm such an idiot sometimes. Cosine negative 1, I don't know why I was making that so hard. Cosine negative 1 of 0.875 means that x equals 28.955. I did that problem horribly the first time. So then we just do that divided by 2, and we take the tangent of that number. Tan of that number, second answer is equal to 0.258. Man, I don't know what I was thinking the first time we started that question. That's got to be C, I think. Number 18. Number 19, 30,744 residents. Guys, but you see that by skipping those questions, I never thought that those were going to be hard, and I got to make sure, I'm good on time. I never thought that those were going to be hard, but I wanted to save them so that I didn't make a simple mistake, or I wanted to move on when I didn't feel like I had answered enough of the questions. 30,000 residents, 2496 voted on a referendum. A total of 38,000 of the 2 counties voted yes. Same percentage of voters voted in each county voted. How many of the residents voted yes? Okay, so 30 total of the same percentage of the voters. So it's the same. This is a good one to just plug it in, right? Residents voted yes. So Leon was, if they voted 10,248 divided by 2496, we get 5. Oops, 10,248 divided by 2496, 0.5. And that was for that. Okay, and then 38. What's 30? So it's not 15, so it's got to be bigger than that. I think it's got to be C here, right? Because 15,372 divided by 2496 is equal to 0.75 times 3744 is 23,000. Yeah, it's 15. C. I just plugged in the numbers to figure out what value 15,000 was of Leon County compared to the total number of residents. Found that percentage and then kept going. I think these are good. If cosine is equal to tan x, which is the following is possible radian value of x. Where's cosine equal to tan? 0 over 1. That's sine over cosine. No, that would be 1 over 0. That doesn't work. 0.67, negative 1. I don't think any of these work. I don't think it's at 0. Right? Because tan is equal to sine there. It's undefined. So it's got to be at 0.52. Dang it. I really want to answer that one, but I'm going to skip it. This one I should be able to answer. What's my time? Okay, we got a few minutes left here. Figure 7 shows the portion of the graph y equals 3 over x. What is the sum of the areas of the 3 inscribed? Can I come up with like 200 here? 81, 36. That can't be right. I'm gonna go 200. This is definitely how you solve for this one, guys, but I don't know what I'm doing wrong here. 2 times 81. 4 raised to the 4. Plug in for x. I'm gonna go. I think it's. I got 200. I feel like I made a simple mistake. I'm gonna go with D for number 26, but that's one where I'm not being disciplined. It's hard sometimes to be disciplined through this, guys. 2x. So this is basically where f of 2x plus 1 for all numbers x. If I plug that in. Oh, for all real numbers x. Okay, so if I plug that in, what gives us that value? 2x minus 1. X minus 1. 2x minus 2. X negative x plus 1. 2x minus 1, no. X plus 2. I think it's going to be x minus 2. If I put that in, that's 4 minus 4. Yeah, if we plugged it, oh yeah, wait. It's gotta be C, right? If I just plug that in, that value's gotta be 4, yeah. It's gotta be C. I'm just plugging in those values for x. What's our time? Gotta keep going, guys. Let's see, which of the following? No, good. Inscribed in a triangle, semicircle. What is the area in terms of theta? The area would just be, I don't know. I gotta skip that one, right? Hopefully we've answered enough of these questions. Got that one, good. I feel better about that. Intersect in a line, another, I don't want to do that one looks too hard. N factorial over n factorial equals n squared. Oh, those are both squared. Wait, that one's pretty easy. Squared. Yeah, wait, that one's, because the factorials cancel. That one's got to be D, I think. 43's got to be D because you can square both terms. You can put those, you can distribute and then you can get rid of the factorials, I think. The radius of the cone, so time. About a minute left. We got to keep moving. It's the easiest one. And how many ways can 10 people be divided into 2 groups? One with 7 people and the other with 3 people. It's got to be a lot. I'm gonna can't do that one. Dang it. Positive rational numbers. So the following is an element that is less than any other in the set. That one either. Which condition the following is positive? What's your time? 25 seconds left. I don't know which one's the easiest one to answer. Which of the following is the element is less than any other? Set a set of positive rational numbers? No. Set of positive numbers R, so set R is greater than. I'm gonna go with A there. I don't know. That's bad, guys. I'm not being disciplined. 2 groups. I gotta be disciplined on this. Radius of the cone. What's our time? Oh, we're out of time. Okay, guys, that's it. That was a lot, okay? So again, our goal here is to try to figure out how many concepts we know how to do, okay? And again, we're trying to get to a 45 out of 50 mark. Sometimes it doesn't work out. I honestly thought when I started that this wasn't gonna be that hard to get 45 out of 50 right, but I was talking too much or something happened, right? Where I got flustered a little bit with a couple questions that I should have been able to answer right away. This one in particular, number 18 was one I definitely should have answered correctly the first time. It wasn't that hard. Same with that cubic function, and that just kind of throws you off. The key is in any given moment, I was thrown off. That I should have answered those questions correctly, and I didn't. But my goal has not changed. Maybe on the perfect test day you get an 800. But if you don't and you get a 780, that's still an incredible score that you can send into colleges. So even if you have that moment of being flustered, you can still do really, really well on this exam. And our whole goal in this is just not to answer questions, omit questions. Like you saw, number 35, which is that cone problem, I really wanted to answer that. I think it was 35, wasn't it? Where's that? 35, I feel like. No, 35 is the triangle. I really wanted to answer that question, but I really didn't know exactly where to go. So now I'm going to try to take a step back. I'm going to realize that I didn't know how to do that problem. I'm going to look at my test corrections to think, okay, what do I need to do to improve this section of the test? And then I'm going to go back and review those concepts so that the next time around, I'm never going to miss those concepts again. So let's see. Again, the whole goal, though, is that the most important thing that I can try to communicate to you guys today is that you don't need on any SAT Math 2 test, and our goal was -5 here, and we'll put up the answers in just a second. Okay, our goal was -5 here because I think that's probably the fairest bet to guarantee yourself an 800. Okay, -5. But if you didn't get that this time, that's okay. The goal remains unchanged. We still are trying to answer as many questions as we can on any given day to guarantee our highest potential score, regardless of if we get flustered or if we're talking too much. The times seem to go pretty quickly there, and so again, maybe next time I'm not talking as much, right? But let's see if we can find these answers. See if we can find these answers. I found them online. Reddit is a great resource for this stuff, guys, if you're ever looking for it. So let me see here. We'll post this test form. We won't post the answers, but if you search it on Reddit, you guys can find it. But we'll post the test for the SAT Math 2, or at least the link to where I found it. All right, let's go through this, guys. So let's see how we did. Okay, so number 1 is B. That's right. Let's see. Number 1 is B. Our goal here, of course, is to get 1 is B. 2 is D. That's good. So again, accuracy is key. 2 is D. 3 is D. 4 is A. Good. That was one that I didn't feel totally comfortable with, but the idea of a plane with 2 points that's usually dealing with 2 sides of a line. Number 5 was C. That's good. Number 6 was A. That's good. 7 was C. 8, 9, and 10 were C, E, A. So let's see if we get those. C, okay, there's a good one with 9, right? I felt like I got it right, and I ended up getting it right, but it's hard to go with that none of the answers can be determined. 9 was E. C, E, A. 10 was A. That's great. Okay, 11 was E. Great. 12, 13, and 14 were B, C, A. 12 was B, 13 was C, that's great. Okay, 14 was A, great. 15 was C, B, B. Guys, one of the things too is you saw, even though I said at the very beginning that you wanted to be, right, we're 15 for 15, so that's a great start to where we need to be. But you saw at the beginning that I felt that I said be disciplined. And even in that moment, it's so hard to leave questions blank. And so you got to make sure in your mind, you're like, okay, be disciplined. Just don't answer questions if you're not 100% sure, because ultimately that will help you. That will help you to not spend any time on those questions, because hopefully we've remained accurate on the remaining questions. 16 was B. That just seems so easy. 16 was really easy. 17 was B. 16 was just just didn't seem like it belonged, but yeah. 18 was the one at least I got it right. 18 was C, but that's super annoying that it took as long as it did, because I was doing, like, none of this stuff here. None of this is necessary. None of this stuff was necessary, and so I wasted a bunch of time there. That happens sometimes, right? You can't control that, but the key is to stay focused and still try to answer as many questions as you can correctly. 19 was 19. Oh no, it was 9. Did I screw this one up? Oh shoot, guys. This was wrong. 19 was wrong. So first one I missed. Okay, 19 was not C, it was E. I think I solved for the wrong thing. Leon was the first one I did, because I was solving for these residents. That one's a bad one to miss. 20, but again, you're running low on time. I got to take my time. I can't rush to the end. 20, by the way, that was correct. 20 was B. Okay, hopefully we don't get any more reds. 20 was B. I solved for the wrong thing for 19. That's frustrating. 21 was D. 22 was D, so that's good. 23 was C. That was right. That's good. 24 was E. 25 I didn't answer. 25 was E. So that's just omitted. That's okay. Right? So we'll just put we'll put this in purple. That's an omitted. Omit. Okay. 26. 26 was D. That's good. 26 was D. 27, guys, 27 was C, D, C, D for the next ones. 27 was C, 28 was D, 29 was C, that's good. That was one I answered at the end by plugging in. For functions, make sure you understand those functions. And 30 was D. 30 was one I felt really comfortable about. Like I said, I feel good about the geometric problems, and so those are the ones I wanted to answer first. I don't get caught up on one earlier, and that's why I'm frustrated with number 18, was because I feel like I know trig really well, and I started the problem off wrong to begin with, and that threw me off, and it shouldn't have, because that really wasn't that hard of a problem. 31, yeah, I plugged this one in my calculator, that felt good. 31 was E. 32 was C, that's right, that's great. 33 was A, great. 34 was C. 35 was one that I omitted. I didn't feel great about 35. Okay, so I'd spent some time on it, but that was an omit there. Okay, 36 was A. 37 was A, great. So those are both right. 36, 37. 38 was that log problem. Was it D? Okay, good. That was D. I didn't feel as comfortable in that one, but it was D. 39 was A. 40 was B. So guys, we're actually kind of rolling along here. And again, it's the focus on not answering questions that throw you off. I had a few missteps. Like I had probably 2 questions where I had started it and I probably shouldn't have. Or no, one I should have and I just made a simple mistake. The other one I probably shouldn't have started like 35 or whatever that was. But nonetheless, you still try to answer as many questions as you can, even when your circumstances aren't the best. So omitted number 41. 42 was D. 43. 42 was D. 43 I missed. Dang it, guys. So I can't miss any more. I haven't been penalized yet because it's only 0.4 off right now. But 43 was not D. That was should have been B. That was one I was struggling with at the end. I hope I didn't miss any other questions because I'm gonna run out of leeway here. 44 was an omit. Let's see, 45. Did I get 45? 45 was C. 46 was B. So that's good. Okay, 45 was there. Good. Okay, 45. 46 was B. 47 I omitted. Okay, 47 was an omit. That's good. I don't know. Let's see. 48 I answered late. 48 is A. Great, guys. That was one where I probably should have been more disciplined. I didn't think about it, and you guys have already seen on the ones that I wasn't as disciplined, like that factorial one we just saw. I didn't get that one right. 49 was D. That's right. 49 was D. And 50 I omitted. So let's see how we did, guys. So I think, and again, our goal was to only omit 5. I know I missed 2, so that's not great news. Hopefully the scale's in our favor. Right? 50 I omitted, that's 1. 47, that's 2 omissions. 44, that's 3 omissions. 43 I missed, so that's 4 off, right? 4.2 off. 5.2 with 41. 6.2 with 35. I missed another one, right? 7.2. Did I miss? Yeah, 19 was 7.2. Did I miss any? I omitted. I think that was 7. Oh, 7.4, right? Because I missed one of those. I think it's 7.4. So missed. So minus 7.4. So I lucked out, guys, that I only missed 2 questions. So you basically on the SAT Math 2 test, you basically get 2 question leeway because this is going to end up being right. It's going to be 40. Let's see, 42.6, and the SAT does round up. So basically, you get a 2 question leeway before you drop a point. So 42.6 would round up to a 43 out of 50. Right? I missed 2 questions. I omitted 5. So the breakdown is, if you guys are practicing, your breakdown should look like this. Okay, your breakdown should be minus 5. I'm sorry, you say 5 out of 50 omitted, right? 5 out of 50 omit, 2 out of 50 incorrect, and 43 out of 50 correct. And if you guys have watched our AP Calc videos, you know that 43 out of 50, while that might not be a perfect score on this test, it could be, right? It's a scaled score, so it could be Because again, you don't need, like just on the AP Calculus exam, which is heavily scaled, you don't need to get every question right to get a perfect score, to get a 5 on the AP Calc exam. Same thing applies to this exam. I'm not trying to find every question to do, because there's no point. You don't even see, colleges don't even see that you got 43 versus 50 out of 50. Those are all the same score. So all our goal is to go into this test is to remain calm and try to get as many questions as we can correctly. On this one, we got 42.6 technically, which rounds up to 43. And that scale, so guys, we got super lucky on this one. A 43, just like it was on one of those tests, a 43 actually was an 800 on this. Okay, like I said, I still think that -5, maybe -6, maybe it should have been -6 to start. -6 would guarantee you probably an 800 on any given SAT Math 2 test. But we ended up, because we had a 2-question leeway, we had a 42.6, right? 42.6 out of 50, because we took away 2 points, right? This should be -0.2 times the 2 questions we missed, which would be another 0.4 off. So we add that, so we ended up missing -2.4 on the incorrect answers. We missed 5 here, which gave us 42.6 out of 50, which rounds up to 43 out of 50. And coincidentally, when the scale is in our favor, even when we don't have the best day, when we're talking out loud, when we're doing all this stuff, you can still end up with an 800 by simply just making sure that you're staying focused throughout. Okay, that if even in the worst possible case scenario, if you stay focused, if you make sure that you're not feeling too overwhelmed, if you feel like you are moving through the questions to the best of your ability, and you're finding the ones that you can answer, you can still get an 800 even if your circumstances aren't perfect. Even if you waste time on a question, all that kind of stuff doesn't really matter. If you go into the test thinking, I'm only going to miss, I said earlier 5, but I'm only going to miss, I'm going to find 6 questions that I can omit. And rather than spending time on those 6, I'm going to apply that to the other 44 that I can get right. And I'm going to guarantee I get those 44 right. I'm going to leave those 6 blank, because in this case, we got a little bit lucky here. But in this case, we actually missed 7, right? And missed 2 of those questions. And so we ended up with an 843 out of 50. That's not always going to be the case on the scale, but it just means that this test was a little bit harder than other tests. And so 7 incorrect answers, or 7.4 incorrect answers, ended up being a 43 out of 50 and still translated to an 800 overall in the exam. Okay, so guys, again, hopefully all of that stuff makes sense. It's so important to focus on this idea of pass 1, pass 2. In pass 1, you're trying to find all the questions you 100% know how to answer. Pass 2, you go back, you look at the more time-consuming questions, trying to get to that number, that floor score that you set for yourself. I'm going to answer this many questions correctly. If I can do that, I know that score is going to translate to a 780 plus no matter what, even if I end up missing a few more than I expected. Okay, so again, hopefully all that makes sense. If you guys have any questions on this, don't hesitate to comment below in the comment section. Otherwise, I hope you guys enjoyed the video. I hope you learned something about the scale. I hope this makes sense in terms of the real-time video as you guys go through this. And yeah, guys, hopefully we see you in our next videos, and hopefully we see you in one of our classes soon. So don't forget to subscribe to the channel if you guys want notifications on videos in the future. And we hope you have a great rest of your day. Good luck on your next test. Great job today, guys.